Okay, let's have a look at factorization then. Here, when we did expansion of brackets, if you look at the two lines, you get 3 2s are 6x and 3 5s are 15, 6x plus 15. So that's how you expand brackets. The reverse process, where you take out what is common, is called factorization. So here there's a 3 common, isn't there? So if we look at 6x plus 15, there's a 3 common here and here, so put that outside a bracket. And then we need to put the pieces in the jigsaw together. 3 times what gives 6x? Well, this first term would be 2x, wouldn't it? And 3 times what gives 15? Well, we need a plus 5 there, don't we? So that's the process of factorization in principle. So here what's common is a 7. Take that outside a bracket. What needs to go here? Well, it will be the x. And we need a plus 2, don't we? What's common here? There's an x common, isn't there? Nothing else. So the other term must be an x to give the x squared, and we need a plus 3, don't we? Here there's a 2 common, so 2 goes outside a bracket, x rather, and then we need 4y, don't we? And then the next one, what's common? There's a 2 common, but there's also an a common, so take a 2a outside, and then we'll have a 3a left inside here. And the 2a is taken out, so we have a minus b left here. And we can check by just expanding it in our mind's eye. 6a squared minus 2ab. Here what's common? There's an x common, isn't there, all the way through? But there's no y common, so it's just an x. So what do we need to put in those 3 spots? Well, in the first one we need nx squareds. In the next one, we've taken one of the x's out, so we'll just leave an xy. And then we've taken that x out, so we're just left with minus 4y squared. Okay, good. So here, expand the brackets, 2 for the first, 2 for the second. 3, 4. And then that's what we did with expansion, wasn't it? We got x squared. Plus 3x plus 2 more x's is the 5x here. And then 2 3s are 6. So the first line gives the first term. So this is the key to unwrapping it. First line in the expansion gives the first term. And then the last line, see it, the 2 3s, so last line is last term. And then the middle 2 lines, lines 2 and lines 3, the 3x and the 2x give the middle term, so middle lines give the middle term rather. Okay, and that's the key to factorization actually, to unraveling it and doing the reverse process. So if you think about this expands to that, so this quadratic must factorize back to here, mustn't it? So how do we do it? Well, first line gives the first term. So let's just see the reverse process then explained. So the first line gives the first term. Well, it has to be an x and an x. Then that's the first thing to do. This is the next thing to do. Last line, line 4, here and here, gives the last term. So something times something gives us 6. So let's write down all the possibilities, because we're just doing a jigsaw here. So the possibilities of giving the product of 6 is 6 1s, 1 6s, 3 2s, 2 3s. Then of course you've got minus 6, minus 1, minus 6, minus 3, minus 2, and minus 2, minus 3. Those are all the possibilities. But if you look at it, it's this times that, and that times that. So it's x of these, and x of these, in that, for the middle term, 5x, isn't it? Last line, last term, to give the product of 6. Getting a bit confused here. Let me just get rid of that. So these two numbers give a product of 6, all these 4. But now we look at the last piece in the jigsaw, come back to that now, sorry. Number 3, the middle lines, which is what I was going on to, give the middle term. So line 2, this many x's and this many x's give the middle term. So the middle term is 5. So this many and this many must give rise to the middle term 5x. So this many x's and this many, that would give 7, that would give 7. This would give minus 7, minus 7, minus 5, minus 5. But these two, both, this many x's and this many x's, give 5. So you notice, because this is an x and an x, the 3 and the 2 and the 2 and the 3, it doesn't really matter. That could be a 3 and that could be a 2, or it could be the other way around. Both of them will give the answer we want, because there's symmetry. So I'll put plus 2 and plus 3 then. Let's just check it. I know it's the first time through, but we've got other examples to do in a minute. X squared, so that one's okay. Then 3x and 2x is the 5x, and then 2 3s is 6. So this reverse process is called factorization. I know we spent a long time on that first example, but it should get easier from here on in. So let's have a look at the next one. So x squared plus 7x plus 10, pair brackets. 4 lines, 2 for the first, 2 for the second, lines 1, lines 2, lines 3, and lines 4. So what times what for line 1? First line, first term. Here's the first term. What times what gives x squared is x and x. Second piece, last line, last term. So this times this gives 10. So what times what gives 10? 10 ones, 1 10, 5 2s, 2 5s. Then you've got minus 10, minus 1, minus 1, minus 10, minus 5, minus 2, minus 2, minus 5. So one of these 8 possibilities. So that was the second piece in the jigsaw for the last line, last term, which is 10. Now to piece it all together, you look at the third clue. Middle lines, middle terms. So this many x's and this many x's needs to give rise to 7. That would give 11, 11, minus 11, minus 11, minus 7, minus 7. It's one of these two, isn't it? There's symmetry in the problem, so we could have written 5 2 or 2 5. Either one is correct. So plus 2 then, plus 5. So we get x squared, plus 5 plus 2x's is 7x's, plus 10. So that's done again. Okay, next one. X squared plus 9x plus 8. So, again, pair brackets. 2 lines for the first, 2 lines for the second, lines 1, lines 2, lines 3, lines 4. Okay, so first line, first term then is x squared, so that would be an x and an x. The last line, last term is an 8, so that's 8 ones, 1 8s, 2 4s, 4 2s, minus 8 minus 1, minus 1 minus 8. These are all the possible combinations that give two numbers that give rise to a product of 8. Okay, we got 9 here, so I hope you can see straight away, now we're starting to get used to it, that the 8 and the 1 and the 1 and the 8 are the ones that fit the jigsaw. So plus 8 plus 1 will do. Let's just check it, x squared. Plus x plus 8x is the 9x, plus the 8 at the end, so that's factorized. So that's that one. Next one now. So practice is all you need with these, and then we start to become more familiar with them. This one, so a pair of brackets again, it's the same every time. 4 lines, 2 for the first, 2 for the second, 1 2 3 4. Remember what we said? First line, first term. So it's x squared, so that's just an x and an x. Last line, last term is a 3, so 3 ones, 1 3. Minus 3, minus 1, minus 1, minus 3 are the only possibilities. Now we're looking for that's the last line, last term. This times this for line 4 gives plus 3. Well, it has to be one of these two, and either one will be fine. So plus 3 then, plus 1. And we're done. Just check it. X squared plus x plus 3x is plus... Oh, it's a minus 4, isn't it? So it's not those two, it's one of these two, isn't it? Because it was minus 4. So when we double check it, we make sure we avoid any silly mistakes. When we didn't notice the minus 4 there, for example. Next one then. Here, pair of brackets. So hopefully you're starting to get used to them by now. Lines 1, lines 2, lines 3, lines 4. Line 1, first line, first term, x times x gives x squared. Then line 4, minus 12. What products give product of minus 12? 6 twos? Minus 12, isn't it? Minus 6, minus 2, or minus 2, 6. And then minus 3, 4, or minus 4, 3. There they all are. So those are the products that give minus 12. Now the middle line, this many x's, and this many x's, this many and this many x's, needs to add up to 4. So we need to look down to this many and this many needs to add up to 4. It's only that one there, isn't it? See it? 6x minus 2x is 4x. So we need a minus 2 and a plus 6. So let's check it. X squared plus 6 minus 2x's is plus the 4x's, and then plus times a minus is a minus. 6 twos are 12. So that's good. Now we move on to these ones here, which are slightly less trivial. So let's do a few of these. Here it's the same process, but it's just not quite so simple. 4 lines, because we've got a 2x squareds here. So the first line, first term is 2x squared. So what times what gives 2x squared? Well, it's clearly 2x and x. And because everything's empty, you can put the 2x here or the 2x there. It doesn't matter because everything's empty. It's the first thing we've filled in. But there's non-symmetry now, so it does matter which way round we write the next things. Last line, last term is 5. So that's 5 ones. 1, 5. So because these are different, these two will be different from one another, unlike before they were the same, because it didn't matter where you put them because there was symmetry. Now there's non-symmetry. It does matter that you write both of these possibilities down. Then we've got minus 5, minus 1, or minus 1, minus 5. So that's the last line, last term. Now the middle line, so 2x times this, so 2x times this, and then the line, that was line 2. Line 3 is x times this. Needs to add up to 11. See it? Middle lines, middle term. So 2 of these and 1 of these needs to add up to plus 11. So it's not going to be the negative ones. 2 of these and 1 of those. It has to be that, doesn't it? So 2 of these, that's where the 5 needs to go, on that side. And the plus 1 can go here. Let's check we got it right. 2x squared. 10 plus 1 is 11x's. And then plus 5. So that's good. We'll do one more. I'm going to leave the last one because we're running out of time on this vid. So I'll try and squeeze one more in if I can. So here we got 3x squared, haven't we? So, but the same principle applies. So first line, first term. What times what gives 3x squared? So it would be 3x and x. Then we've got minus 2, the last line. Minus 2 times 1 or 1 time minus 1 times 2. It's only those two possibilities. Give a product of minus 2. So then middle lines, 3x times this and x times this gives minus 5. 3 of these and 1 of these. Well, it has to be this one, doesn't it? Minus 6 plus 1 is... So this is minus 2, and this is plus 1.